All right, part 3. Had to add 3 parts. Sorry about that, you guys. It's just a long review. So here we go. We're almost done. Number 19. If a equals 2 over x plus 1 over y, what is the value of 1 over a? So you can see they're asking to take the reciprocal of a. Now, quick little lesson. 1 equals 1/3 plus 2/3. Now, can I flip each piece and have it be true? 1 equals 3 over 1 plus 3 over 2. Flip this, which is 1 over 1. Flip this, 3. Flip this, 3 over 2. You can see this is no longer true. So how do I take the reciprocal of this side? Well, you just answered your question. 1 over a means flip all of this. So that would be simply 1 over this whole side. 2 over x plus 1 over y. Now, concentrate on the denominator. We need common denominators. So I'm going to multiply this by y and this by y. Multiply that by x, that by x. So that turns into 1 over 2y over xy plus x over xy. I got common denominators. So I'm going to go 1 over 2y plus x over xy. Remember, if I have a fraction divided by another fraction, I take this, flip it, and multiply. So what's anything times 1? Itself. Where's that answer? Letter C. Number 21, you can see they're not worried about well, they're not talking about identify what x can't be, but you need to be careful right away and say x cannot equal 2 because you might have an extraneous root down the road. Well, what I'm going to do here is I'm going to go ahead and take a look at this problem here and just first of all get rid of those denominators. So I'm going to go ahead and add up so I don't forget that negative. But as you can see, I'm going to multiply by x minus 2. So this times this, gone. This times this would be x squared minus 2x. Sorry about it, it gets a little messy. And these just cancel when I hit it with that. So over here I got x squared plus x minus 4. Now the x squareds cancel. I'm going to add 2x to this side, add 2x to that side, add 4, add 4. So I get 3x equals 3, divide by 3, x is 1, which is letter B. Now, if I would have gotten x equals 2 as my answer, and that's the only answer I got, that'd be an extraneous root, I'd be looking for no solution. All right, we're getting there, guys. So another quick little peek here at the rules of horizontal asymptotes. It says, which graphs have a horizontal asymptote y equals 2/3? Select all that apply. Well, if we take a look at this, if the top, well, let's go to this one. It jumps out at us. If the top degree equals the bottom degree, you just take the coefficients off, and that becomes your horizontal asymptote. And you can see we got a tie here for letter B, and it's 2/3. So we're like, yeah, there's one that jumps out at us. If we take a look at, let's see here. All right, so I wanted to show you something about letter C. So we know that y equals, ignore the 2/3, y equals 1 over x is our parent function. And we know by the rule that if the top degree is less than the bottom degree, which we have right here in this situation, and this is our parent function, so we should kind of know that our horizontal asymptote is y equals 0. But then if we put a little plus 2/3 back in our head, it would move this parent function up 2/3. So our horizontal asymptote would be y equals 2/3. So that one's a little tricky, but it qualifies. Now this one, what you can see here is that it doesn't qualify as the top degree equaling the bottom degree. So that's the tricky part. You're looking at the 2/3 and you're thinking, yeah, but this actually qualifies as the top degree is less than the bottom degree. So really the horizontal asymptote for that one would be y equals 0. So that's not true. And then we got the same thing here. The top degree is less than the bottom degree, so the actual horizontal asymptote would be y equals 0. Yes, but they're trying to bait you with that 2/3 there. But you got to remember this rule: the top degree less than the bottom degree, just like the parent function. Horizontal asymptote y equals 0. So that's a pretty tricky problem there. Grand finale. Rectangle has area, that crazy looking stuff. Remember, a rectangle's area equals length times width. So really, we got to take the area, which is x cubed minus 15x minus 4. The width is x minus 4. So we're equaling the length times the width, x minus 4. What is the length? Well, mathematically speaking, you got to divide both sides by x minus 4, which makes sense. So now we're going to go ahead and use some synthetic division. So I'm going to take that. What minus 4 is 0? 4. Put it in the cheap-monk nest. I got a 1x squared, so 1 there. There's no 0x squared, so I got to put a 0 there. Negative 15, negative 4. You got to remember that 0. Drop the 1. Multiply, add. Multiply, add. Multiply, add. No remainder, and we should have known that because this definitely goes into this. Now, the highest power of our numerator is 3, which tells us that is 1x squared plus 4x plus 1, which is letter C. We did it.